Picture this. You're looking down from a sprawling cinematic aerial view at a facility so incredibly massive, it literally stretches all the way to the horizon. Welcome to our latest explainer, where we're exploring the staggering scale of the world's largest packaging machine. It is a true titan of transit. I mean, this isn't just your run-of-the-mill factory. It's a photorealistic, modern engineering marvel. We're going to completely break down how this unbelievable behemoth operates step by high-speed step.
To really wrap your head around what we're dealing with here, you've got to look at the mind-bending numbers. We are talking millions. Millions of individual items processed, sorted, and shipped out every single day. To put that into perspective, that is enough volume to fill an entire professional sports stadium right to the brim daily. And when you're operating at this kind of massive scale, there is absolutely zero room for error. A tiny 1% delay wouldn't just mean a few late packages, it would trigger an industrial bottleneck of catastrophic proportions. Which leads us to the ultimate question we're answering today. How do you flawlessly package millions of items a day without the whole system just grinding to a complete halt? Okay, let's dive into this by dropping down from that massive aerial scale right into the high-speed action of the factory floor.
Section 1. The high-speed assembly line.
It all starts right here. You can hear the rhythmic clacking of the vast conveyor network. Raw materials are just rushing in from every conceivable direction, completely merging into a single, unified river of commerce. The belts never, ever stop. They just continuously feed the beast with relentless, perfectly engineered efficiency.
Once those materials actually hit the line, we enter this lightning-fast sequence. First, AI sensors instantly scan the rushing items. Second, robotic arms lock onto the exact coordinates of the moving object. And third, they execute a precision pick. We are talking sub-millimeter accuracy here, happening in fractions of a second. If you were standing right there on the floor, the robotic arms would look like an absolute blur, but underneath it all, it is a completely controlled algorithmic dance.
Instantly, we drop right into the whirring maximum velocity core of the whole machine, the high-speed filling process. Whether it's liquids, powders, or individual components, they're injected into their packaging at a rate that honestly defies the human eye. This is industrial velocity at its absolute peak, making sure those millions of daily units are met without skipping a single beat. And right on the heels of that, we have the automatic sealing technology. The exact moment a product is filled, it is hermetically locked. The precise mechanical jaws snap shut, instantly sealing out the environment and totally protecting the product. It's this crazy rapid-fire sequence: fill, seal, move, fill, seal, move, over and over again.
Section 2. AI and quality control.
Let's look at the tracking mechanisms for a second. Step 1 is label printing, and Step 2 is barcode application. Because of the blurring speed of the assembly line, these labels are practically fired onto the products like lasers, but they're absolutely essential. This barcode is basically the product's passport for global tracking. It tells the warehouse, the shipping trucks, and ultimately the consumer exactly what it is and exactly where it's supposed to be.
Now, what's really interesting about this slide is how they actually know the label is right, or if the seal is perfectly tight. Enter AI-powered quality inspection. You can think of this algorithm as a ruthless, all-seeing bouncer for the assembly line. It uses hyper-advanced cameras and real-time evaluation to scrutinize every single product. If there's even a micro tear in the packaging or a slightly misaligned label, the AI catches it instantly. And let me tell you, the AI's judgment is final. If a product fails to meet the gold standard, you see this incredible mechanical rejection. A pneumatic arm or a sudden diversion track literally punches the defective product right off the man line. It's harsh, it's incredibly fast, and it guarantees that out of those millions of items, only the absolute flawless ones actually make it to the end.
Section 3. Palletizing and warehouse transit.
First up, in the heavy lifting finale, is the carton packing system. Now, this isn't just casually dropping items into a box. This is rapid-fire, geometric precision. The system perfectly arrays the products, folds the cardboard around them incredibly tight to prevent any transit damage, and seals the carton. It's basically a high-speed game of Tetris where the machine always wins, maximizing space and completely minimizing waste.
Watch how seamlessly this builds right into the robotic palletizing stage. This is where the sheer, unbelievable scale of it all hits you. You've got these massive robotic arms towering over the line, effortlessly picking up heavy cartons and stacking them onto shipping pallets with these incredibly smooth, fluid movements. The engineering required to move heavy loads so gracefully and so perfectly aligned, it's a modern industrial masterpiece. Once the pallet is fully stacked and wrapped, it doesn't just sit there waiting around for a human on a forklift. Automated warehouse transports, these amazing driverless, sensor-guided vehicles, slide seamlessly underneath the loaded pallets and whisk them away into the vast, dark network of the warehouse. They navigate the aisles like blood cells in a vein, constantly keeping the arteries of the factory perfectly clear for the next batch.
Section 4. Engineering by the numbers.
So, the crucial point is really seeing the contrast here. An ordinary packaging machine is impressive, sure, maybe handling a few thousand units a shift, but the Titan of Transit? It absolutely dwarfs standard operations. It's not just a little bit faster, it operates in a completely different stratosphere of industrial output, effectively doing the work of dozens of traditional factories completely combined into one single unified machine.
But you don't reach these incredible production speeds without some seriously next-level hidden engineering. First, you've got energy-saving technologies. Massive power regeneration protocols literally prevent the factory from browning out the local grid. Second is safety. Yes, the machines are crazy fast, but humans still oversee them. So, state-of-the-art light curtains, motion sensors, and instant emergency shutoffs are deeply integrated to ensure zero harm comes to the engineering teams on the floor.
Ultimately, it all comes down to a really delicate balancing act. You can't just max out production speed without thinking. You have to balance it equally with energy efficiency and safety systems. This equilibrium is basically the holy grail of industrial engineering. Because if any one of these three elements is ignored, the entire Titan of Transit could just come crashing down.
Section 5. The future of packaging.
And this brilliantly illustrates where we are heading next, because the engineers certainly aren't stopping here. The future innovations we're already seeing on the drawing board are going to push these industrial limits even further. We are talking about hyper-adaptive AI that can magically change packaging sizes on the fly without ever stopping the line, fully biodegradable transit materials, integrated directly into the high-speed flow, and even completely dark factories that operate 24/7 with zero human intervention on the floor.
Which leaves us with this final, epic thought. Look at this sprawling, complex system and really ask yourself, if this Titan of Transit is what we are capable of building today, what on earth will the factories of tomorrow look like? The sheer scale of human ingenuity literally never ceases to amaze me. Thank you so much for joining me on this explainer. If you enjoyed diving into the mechanics of this unbelievable machine, be sure to subscribe for more deep dives into the world's most fascinating engineering feats. I'll see you in the next one.